We are now live, so we'll wait for everyone to come on in, and then we'll get started in about a minute.
It's 9 o'clock.
Yeah, I guess it's 9 o'clock.
Because I started a little late. That's okay.
Okay.
We'll wait about like 30 seconds. People
Okay.
are filtering in, and then we'll go over the polls and
Yep.
away you go. Looks like we are all set to go. Thank you guys for joining us today for Jim Craw's presentation on chemicals. I know you don't want to think about snow and ice just yet, but it's never a bad thing to do it. So we'll get started with some polls. Give me 1 second. Whoop. There we go. The first poll question: what is your primary job function? Highway worker, highway superintendent, engineer, or other? Just so we get a little background of who's on today. It looks like we have a majority of highway superintendents, followed by other, and then some engineers.
Perfect.
Next, we have poll number 2. Get there. Is poll number 2 up?
Don't see it.
Watch. There we go. All right. Who do you work for? Village, town, county, city, state, or the private sector? Okay, it looks like the city edged out the county just by a little bit. And then lastly, we have poll number 3. How long have you worked with highways? Less than a year, 1 to 5 years, 5 to 10 years, 10 to 20 years, over 20 years. It looks like the majority is over 20 years. So we got a lot of experience in the room, Jim.
It scares me a little bit.
So with that, I will turn it over to Jim, and thank you guys again for joining us this morning.
All right, thanks, Amanda. As Amanda said, I'm Jim Craw. Today's presentation will be on chemicals, maybe a little background of some stuff you've already got, and hopefully we can get something that you can use in the future here. Okay. I've lost the control of my computer here. Amanda, did you give it back to me?
Let me, give me 1 second. Control. There we go. You should get a button.
Okay, I guess I got it back here. I think. No, can't.
Okay, I can click for you.
Okay. All right. As a lot of you know, we have a Roadmasters recognition program on different levels of participation. We're up. Where did we go? We got to go back a little bit, Amanda.
Oh, there we go.
There you go. We've always been the LTAP assistant program. It's LTAP, Cornell Local Roads, governed by the state of New York Department of Transportation. As a partnership throughout the country for our training programs. But if you can do the Roadmasters, you can, achieve more. Okay, next. Okay, there's a couple questions in the program. You'll be able to answer just like you did on the original when Amanda was talking about how long you've been here and stuff. Most of all of them are yes, no questions, nothing big, no big deal, just looking for some information. Okay. This is me. I'm the Cornell Local Roads Snow and Ice Control for local highway officials. This is a course that I teach in the field mostly. Hopefully this year I'm going to be going out a few places this fall. I'm the circuit writer for the snow and ice programs for Cornell. Have you considered some salt reduction? Reducing the amount of salt? Yes or no question?
You guys can type that in the Q&A box. We'll tally them up. Got a nice mix of yes and no's and yes often.
Okay, very good. Thank you. If you have any questions, write them, Andy. They can type in, questions and we can answer those later.
Yep.
Okay, thank you. That'll be good next. One of the things we talk about when reduction, and one of the big pushes that's out there today throughout the country or the northern hemisphere anyway, talking about salt reduction and deicers. This thing that's on the screen right now is a schematic of where your deicers go when we put them down. This is by Clear Roads. It's in the best management manual. As you can see, you have your road application, runoff, aerial it moves around in the air, and it can affect the air quality. Most of that air quality is being if you use sands. Some states, after they have an event and they sand the roads, they have to go out within X number of days to sweep everything. This state isn't there yet, but there's always a chance it's going to start happening. The other places that it ends up going to is into the plants on the sides of the roads. Most of the salt or the chlorides that are being put onto the roads end up most of the time is within 50 feet of the road, and it stays in the shoulders or wherever it is, which compacts the soils, changes the consistency of the ground. And the other parts go directly to the waterways. With the waterways, what happens with the water, it gets into the creeks and ponds, lakes, and it settles to the lowest point, and then it basically stops anything from oxygen and filtration of it. And salt stays forever. It doesn't go away. It just moves around different places. The direct runoff goes into the aquatics, and then the soil quality will change. And most of it stays on the road for a while, and then it mitigates out eventually with the amount of water that comes off. Okay. The chloride reduction, we're working on more and more of that for that environmental piece, more than anything. But if we can reduce the amount of chlorides, it's less cost to us. You need good record keeping, upgrading equipment and technology for snow and ice, and then changes to selected materials or application rates. When we do all these things together, we can show a reduction in salts. The one product fits all program, the same application rate for all events. It's not working so well for us. And if it's 30 degrees out, you don't need to put 300 or 400 pounds of de-icing material on the road. You can get away with 100, and if it's staying at that temperature, that's great. It'll go away. If the temperature's dropping, you might have to adjust. But each event should have its own plan. I know it's a little difficult because we have different areas, but each area should have its own plan. If we use the calibrate the units, we'll know what we're putting down. That's record keeping. We'll know how much material we ordered, how much we used, and how much we have left at the end of the season. And the combination of liquids and solids, there is a reduction in the salt use all through. Okay. Level of service. You hear a lot about level of service. I read a lot about level of service. Level of service is basically entirely up to you as a supervisor or your governing board, what they want your roads or streets to be like. There's no one way to say that it's the best, or this is the level of service we want on all our roads. If you're running a 4-lane arterial, you want those roads to be black and dry, as quick and safe as you can get them. If you've got a back road stuff going on, maybe you don't need to apply as much as often. Some departments I know make 1 pass a day. That's what you get. Cost of your labor, all that kind of things, they all come into that. Level of service is always going to be based on your cost, the safety of your citizens, your customers. Environmental responsibilities is becoming more and more prevalent because you're finding more people coming out of the cities that want to be green. And there's nothing wrong with that, but we also have to look at the cost of it. If you have an accident, somebody has an accident and sue you, what's that gonna cost you? Environmental responsibilities. And it's specific to your case. There's no standard for level of service that you can say, okay, everybody's got to have this. A few years back, some reporter got a hold of some information from somebody that said that New York State was going to had a bare road policy. The state of New York has never had a bare road policy. First, because legally, if you said you're going to have bare roads for everything, you're going to get sued the minute there's something on. And that cost becomes, kind of large. Okay, next. Do you do training? Very important. You can type that in. Let me know what you've got there.
We have a mix of yes and no, mostly yes, some no.
Okay, that's good. I'm glad to hear that there's training out there. And I'm glad to know that, there's something going on. We'll get into that in a minute. Okay, Amanda? Training must have buy-in from the management and respect the staff. Trained by outside agencies can be done. Trained from within the agency. If you have enough information inside your agency, you can do your own training. Should include knowledge of snow and ice chemicals use, storm water, and environmental concerns. All these pieces that are in this are only parts of what should be given. When I say buy-in from the management, what happens is sometimes we're mandated to do things and the management doesn't really agree with the mandate. And we've all been through it with our unfunded mandates that we get from above. But the management has to believe in what you're doing. You have to take that seriously as something that you really want to do, and then show your staff that you understand it. You need to understand your program. I know that some of the engineering staff are pretty well removed a lot of times from the day-to-day, the hands-on parts of an operation of a highway department or a DPW. It'd be best if you were a manager that you sat in on the classes with your staff, or did something, because when there's training going on and things change, I mean, like, for example, when I go to someplace, I'll give you a whole bunch of things to look at. New technologies, different chemicals to be used, and those kind of things. And basically when I come, it's just what I will give you is a bunch of tools for your toolbox. You have to make your decisions. And in a lot of ways, you have to look at your cost. I know as a manager, I was a superintendent for 20 plus years. I always had to look at what was the best for us, money wise, and and my constituents, because they are our customers. So we have to look at that. And you should also understand what the storms are doing and how the chemicals are actually going to react to different forms of precipitation. Okay. The cost benefits of training. If you're trained in, you've been using sand and salt forever, which we did. You make the change over to salt. You're gonna realize that you're gonna have a cost change in that. It's gonna be probably a little higher for the chemical, whether it be liquid or solid. But you're gonna find out with the application, as you only use what you need, then that's what you have to do. Compliance with good housekeeping practices, keeping your shop area, your storage area is clean, have the proper drainage, and that it doesn't directly run right out to the creek, stream, swamp, wherever it's going to go to. It has to be left. And track the amount of material you bought, delivered, used, and amounts you can. And then at the end of the year, you should really take a look at all those numbers and put them together in some form. A lot of this will end up working in your benefit when it comes to budget time. When you do your housekeeping, one thing that I found is we're in an MS4 here in Syracuse area. I'm from Onondaga County, right in the middle of the state. We had the EPA come, and the EPA is doing inspections of highway departments, DPWs. They're looking at everything from the storage of your salt to your shop, oil water separators, sand separators in your drainage areas where it's coming out of the shop area, your wash facilities, and outfalls to your creeks, streams, and that kind of stuff. They look at all that stuff. Those fines are substantial when the EPA comes in. They really want to see records, and they want to see that you're doing the right thing. Oil tanks, fuel tanks are inspected. Waste oil, where is it? Where's it go? You just make sure you've got all those things put together. But if you do the reduction of the chemicals up to the road, you will see a definite cost benefit to you. And that all comes back to the training. Train your people so that the last guy that comes in knows what the first guy came in the shop knows, and then try to build onto that. It'll help you immensely in the future. And it also allows your employees to take a buy-in to this as being part of their, it's what they need to do. I know it's hard because everybody's strapped with staff right now, and I don't see it getting any better. So we need to be smarter about the way we do business. Okay. The resources that I use for most of my stuff and that is all available to you as individuals throughout the country. Clear roads, the best management practices. You can get that's online. They also have a plethora of information on your roads. Very good programs. APWA, if you're not involved in one of your local groups, it probably wouldn't be a bad thing to get involved with them. APWA has a winter snow conference that comes in April every year. I've spoke at that once. I had another invitation 2 years ago to go to speak and work with Wolf Nixon, which is the Salt Institute's representative, to do a presentation, and a gentleman from Cargill. But that got canceled because of COVID. The next one is going to be, I don't know, in April in Pennsylvania someplace. Salt Institute has a lot of good information. And then Cornell Local Roads, the LTAP program that I'm involved in. So I am involved in all these pieces. So I gather the information, I can bring it back to you people. But all the information that is coming off in these programs comes from these 4 places and a bunch of other ones, because I network with a lot of different people around the country. Started doing salt brine, making salt brine, and then the distribution of it within our facilities in our central New York region, state of New York, Casanova, Onondaga County. And I also was involved in a federal highways program for the state of New York to allow the state of New York as a whole to use salt brine. So that's available too if you want to see that. So, okay, yep. When we talk about chemicals, we're talking about 2 forms of chemicals. You've got a solid and a liquid. Solids basically, is your salt, and your liquids would be your magnesium, calcium, magnesium, acetates, all the stuff that's out there for sale. And in combination, this stuff works great. Liquids with solids. Okay. Commonized chemicals. Sodium chloride, which is your rock salt. Calcium chloride, which is now most of the time it comes in a liquid. Now, magnesium chloride, organic carbohydrate chemicals, and calcium magnesium acetate. and then potassium acetate. Sodium chloride is the cheapest. It's been the standard for de-icing or anti-icing. It's easiest to handle of all of them. Your calcium chloride in a flake or liquid, mostly liquid now. Calcium chloride, magnesium chloride, basically the same program. What those two products do is it drops the freeze point of it'll melt at a colder temperature. Calcium, magnesium, if used by itself, can have some problems with slippery conditions. High humidity at the right temperatures, can be slippery. But when you take the calcium and magnesium and put it with an organic carbohydrate chemical, what happens is it becomes sticky and it holds that material on the road for you longer. One downfall to the liquid side is it will dilute out faster than your solids, your solid being your sodium chloride. If you use sodium chloride in combination with a magnesium or calcium with an organic mix, works much colder than the 6 degrees or 20 degrees that everybody claims that sodium will only work at. And you can reduce the amount of salt that you're going to use on the road when you're using these products. 2 ways to make this application work is one is to take your salt, sodium chloride, put it on your truck, put saddle tanks on your trucks, and use a magnesium chloride or calcium chloride or magnesium chloride with organic or calcium with organic, and have an onboard pre-wetting system. So when you drive down the road, the salt comes out and your liquid sprays your salt at the proper applications, and you'll have pretty much much faster melting, and it'll stay on the road longer, and it stops bounce and scatter, which is huge. You want to make sure that everything stays on the road where you put it. And there is some anti-rusting agents in the organics because it's a salt-based or a sugar-based product, basically. The other way that you can achieve a sodium that's manageable at colder temperatures is to do a pre-wet or a stockpile mix, or you can buy the salt that's already coated from your distributor. So that's a good program. There's also 2 ways that they do that, as a type 1 and a type 2. Type 1 is strictly magnesium or a calcium. It's sprayed on at 7 to 9 gallons a ton. And it's pre-treated salt that you can buy on a contract, which is about $10 more than the straight salt. But it's extremely effective and it lasts a lot longer and deeper temperatures. And the type 2 is the sodium chloride with your mag or calcium with a organic carbohydrates, which ends up being a sugar, which sticks onto the product. One thing with that is you want to make sure that if you're going to do your own stockpile, make sure that your salt is dry, because it'll suck into the moisture will suck into the salt. If it's wet, then it'll start leaching out on you and it'll run off the pile or out of the pile. Calcium magnesium acetate has been added to like beet juice. It has good qualities. We found the organic and magnesium to be what we like, because it still gets us down to that 20 below zero. We don't have a huge amount below that days, so it'll still work. Potassium acetate is a little more expensive, used on airports and such like that. Okay, that's expensive. Your advantages to chemicals in the solid form. Okay. Okay. So the solids will cost you less, easier to handle, dilute slower because it's larger, it's a larger particle. And salt also gives you that initial skid resistance for, up to, if it's just straight salt, it's probably someplace around 20 cars. And the liquid side, the advantage is it works right away. Whenever you're going to apply any liquid, or if you're using salt, it doesn't matter. The only thing that's going to melt on the road, sand doesn't melt anything. Sand strictly is an abrasive. But when you start getting a pile up of snow, the sand isn't effective even for traction because it packs into the snow and it just starts building hard pack. When you're using the liquids, what happens is it's right away it starts working. So when we added the liquids to the solids, what that did is it started making it right away. And what works on the road when you apply is it becomes a brine because the solid sucks up water. And the brine is actually what's melting it off your material off the road. The rock doesn't do anything until it becomes a liquid. That's why straight salt freezes at a higher temperature because it doesn't have the capabilities of going cold, and it dilutes out. And when it gets up past that 23%, then it will start freezing right away. Liquid's not displaced by traffic. That's when you use a direct application. Pre-treat your roads. You can do that a couple days ahead of time. Spray with liquids, and it stays on the road until the storm starts. And then it gives you a chance to get to your roads a little easier, and it'll clean up a lot quicker. The residual will stay on the road and effective. This Cassidy it's versatile to the point that you can use direct application or you can treat solids with it. It's a good combination. Okay. Chemical forms disadvantages. When solids, like I said, when solids go down and they need moisture to start working, and it also takes time. If it's warm out, the salt will start working within probably 5 minutes. When it gets down around 0, it's probably going to take, if it'll work, it'll probably take around a half hour to start working. So, that's one of the things you've got. Not good for anti-icing. One of the issues you have when you're doing anti-ice is that it bounces scattered and it's displaced by traffic fairly quickly. Because if you drop solids on the road without any liquid with it, it just bounces all over. You've followed vehicles, spreading material, and you'll see it hit down in the middle of the road where it belongs, where it should be applied to. And by the time it gets done bouncing around the road, it's all on the shoulder. There's no need for material in the shoulder. It's wasteful. Liquids are mostly water. If you use, for example, if you use brine, it's 23% is in salt, and the rest is water. Your magnesium's all done with water, calcium's done with water, and ag products to thin it down to work. It's not thick for thick snow. One of the problems, if you get hard pack and you try to use it, it'll just kind of stay on top. It won't go down through it. So the best way to do that is a combination of liquid and solid on top of the hard pack, and it has to work down through. Ideally, you don't want it to get to the hard pack stages So that's why I want to get your material down quick, and possibly before the storm if you can do a direct application. Rain will wash it off the pavement, dilutes it out. And in certain cases, it can be slippery, like I was talking about the mag and calcium can be slippery. We've been using it here, like I said, for 20 years plus. We really haven't realized that too much. We keep our applications down as low as we can, and then we reapply salt at a smaller concentration if we're using rock. Okay, man. This is the amount of ice that will work, when you're going to use sodium chloride with, rock salt, calcium, or magnesium. At 30 degrees, sodium will do 46 pounds of rock, of ice, snow. Magnesium at 47, which is, it's a pretty good number. The more you can melt, the faster it's going to go away. But as you see, as you go down in temperature, at 5 below, your rock salt is going to do 3 pounds, and calcium is around 3, almost 4. Magnesium is at 5. But when you're using your products, you have to take all that into effect. The most accidents, the most savings you can get is to get within the first half hour of a storm, get product on the road, and it'll save your roads a lot. Okay. This is just a phase diagram. Phase diagram is where things melt, and when it comes out of where the capability of your melting action stops. As you can see, your freeze point for salt is at 23% in 23%, which would be like a brine, and that's where even if you've got rock salt and it gets to 23, when it starts melting, the water gets to it and it goes down, and that's where it actually works the best, is at 23. But as you can see, it's still going to work all the way down to that point at a lesser concentration. But as the concentration gets diluted more and more, it freezes faster. So if you look at your diagrams to the right of that, and that just shows you that your potassium acetate, I think that is, it goes longer and deeper. But like I said, it's a cost thing. Everything else is pretty much, exactly on the left and the right, but it shows you where, once you start diluting, how fast it comes out of concentration, and how much less it actually works for you. Okay. Organics. Is a carbohydrate enhanced product. Let's see the next slide. I think it tells us. Okay, this is what organics are. Basically, they're sugar byproduct of an ag product, whether it be beets, molasses, corn. There's some studies being done right now on the beets. There's been some odd things going on with the beets, and they want to try to use, instead of using the whole beet, they want to try using the beet stems because it's a waste product. They're trying to process it to make it a better product environmentally. We'll see where that goes. I'm not sure exactly the whole process, but organics are made from make sugar, beet and whiskey making, corn fermentation, and other crop fermentation or processing. So basically what we're getting is the leftover stuff that they can't use in the food industry or what, whatever they're using it for. But as of late, when it first started, the inconsistency in most of these products were all over the place. Now that they've come up with better processes, more consistent, and most all the products out there today are truly a lot better than they were, and then the consistency is super. One other thing you have to do with these, if you're going to use an organic additive to whatever you're doing, my suggestion is whoever the vendor is that you've got, make sure that they've got a testing laboratory, hopefully on site or reputable unit, that they can certify what that product actually is, and they can take a test of the load that you've received and give you a readout of what it actually contains. Sometimes the organics can have some other things in it that you may not want that in your area. The state of New York is now in a process of doing another study for the Adirondacks salt use. Most of the roads in the Adirondacks used to never use salt or very little salt, and the state included. Now that salt's become the weapon of choice, the salt applications they found is extremely high, and it's starting to get in some of those pristine lakes and streams. Lake George did a salt reduction study a few years back. They've reduced the salt. They've also done a lot of infrastructure for the drainage to capture before it gets into the Lake George area. Good things, but when the state gets done, I think we're going to have to we're probably going to find some newer regulations coming out. It'll be more record keeping kind of things, and use in low salt areas, higher salt areas, depending on where you're going to be at. But we're all looking at the drinking water, and we're looking at the aquifer to make sure that it doesn't get in. There's been a lot of cases of road salt mitigating to people's drinking water, springs and wells. Some have been found to be a bad thing, and some have been found to be not what they had originally said, because there is salt in the ground. The other way salts can get into the aquifer is through the agricultural business. If you've ever looked at your planter or a ceramic clay pots, you'll see that if you've done a lot of fertilizing of your plants at your house, you'll start seeing salt appear on the outside of the clay pots. So fertilizer's got, if it's got magnesium or calcium or whatever's in them, there is chlorides in those too. So they're looking at that stuff along with it. Okay. The advantages of the organic and carbohydrate chemicals is it's less equipment corrosion, sticks to the road much better because it's gooey. Seems to prevent ice bond to the pavement. I think I've got a slide on that. Less corrosion again. Residual stays on the road between the storms. If you apply through a storm, with an ag product, what you'll find is that the more trips that you make, more events that you go with, the better the residual is, so that the next storm comes along and it starts melting and keeps any bond of the road up. But what we found in the last few years here is we get a storm, get an inch or two of snow, and we get another inch or two of snow, and it starts building up for us, the residual, and then it rains. So when it rains, then your residual is pretty much gone. There's less environmental threat of the product. It's visible to the public, so there's an education side to that, to let the people know what you're doing, and just have the information available to your customers, so that they know that we reduce the amount of material on the road, and it will drop the temperature down of your freeze. Okay. Disadvantages. Probably if you could use it 100%, it'd be great, super, but it has to be cut because it has to go through the spray nozzles, whether it be when they mix it at the plant or when it's on your truck. It does have an odor. One of the odors that you'll find if you use any liquid, regardless if it's salt, brine, or organics, is if it isn't mixed periodically in the tanks, or storage tanks, or 5,000-gallon tanks. If you don't have a way to stir that up, it'll start basically rotting, and it'll have such a stink that you won't be able to get near it. So you need to be able to turn that material over inside itself. There is less infrastructure corrosion protection. That's always a bone of contention. I get concrete engineers telling me that we're the reason that everything is rotting. Could be, but on that piece, if you've got a bridge deck, sidewalk, sidewalls, a lot of times what happens is they don't put the re-rod deep enough into the concrete, and of course it's going to mitigate into the concrete, and then it's going to start rusting your steel, and then you'll see the red spot start on your surface, and then shortly after that it'll spall. One test that was done on a group of bridge decks, I think it was Wisconsin with Minnesota, someplace Midwest, that they did a study on the salt mitigation for where does the salt go. They put traps at the bottom of the drainage on the bridges, and they collected all the water that came off the bridge. And what they found is most of the salt that was being applied to the bridge deck actually ended up running off in the bridge deck, and then was collected down below underneath the bridge in settling ponds. So that's one thing to look at, that most of the material ends up off the road because it melts and runs away. Here in Syracuse area, we had a couple accidents on 81 back a few years back. The state had always plowed up against the barriers, the walls of the bridges, and what happened is that it became a ramp. Some people had been driving on it, lost control of their vehicles, catapulted off the bridge using the snow and ice that was built up on the edge on the walls. So now the state has to go and scrape those walls down periodically to keep the amount of snow off the bridge, to not create a ramp. They also have been using salt brine mixed with calcium and magnesium, or magnesium and organic, to spray down the walls after they get done, and they seem to be having a lot better protection, it melts off. And the cost is a little higher because it's like $1.30 something a gallon. It costs you, but at the end, you don't have to make as many passes. It also has some biological oxygen deficit issues that goes into your streams and whatever. But there is not a chemical on the market that we use in New York State pretty much. I can't say everything, but most every product that we have has a bad side effect to something. So what we need to do is reduce the amount of that we're putting down and still be effective to the point that, we don't have issues. Okay. Okay, this is what I was talking about before with the anti-icing strategies. If you look at your screen, you'll see a brine layer, your pavement layer, your brine layer, and your snow and ice layer. If you do anti-icing is before the storm or at the beginning of the storm. You get a layer down on the ground. Salt has been tried. It does work, but effectively, it usually ends up going away, bouncing away, or traffic will break it. Once you get snow and ice on the top, if you use liquids, and that's what we use, that's only because that's what we use, you won't get a bond to the pavement. It's like a 32nd of an inch. That's all it takes to bond that snow to the road. And anybody that's been in the business any length of time has seen that happen. And many times it happens because of the traffic is on it before we get to it. So what happens is it starts building up hard pack. And if you get hard pack, you're going to probably make 3 or 4 extra passes on that road after the storm to try to get them cleared. If you can stop that bonding to the road, at the end of the storm, make your last application, plow them off, slush, it's gone, then you won't have to be back, 4 or 5 times. I know in my case here, I have state road next to me and I have county roads next to me and I have town roads. Within my jurisdiction, we haven't had any hard pack since I started using anti-icing strategies, which means that at 3:30 in the afternoon, after the storm is finished, if it stops at 3:30, 1 day, 2 days, 3 days, we can plow those off and we're gone. Now, in the other jurisdictions, they're out at night scraping and they're out the next day scraping. In our cases, we don't do that. We haven't done that. So the next one, man. This is what happens when you have a de-icing strategy where you don't have anything on the road and it packs up. What you can see on here is the path of the chemicals on the left-hand side. What you have to do is you have to basically over-apply chemical to the hard pack. And hopefully it'll work its way down through the pavement. Then it'll start breaking it up. But once you get ice on the road, you get a hard pack on the road, it's almost impossible to penetrate that hard pack. So you have to apply and grind. By doing that, eventually it'll work its way down through the tires to get to the pavement, and then it'll start mixing, and then you'll have a slushy slush. It ends up being pretty nasty. One way that's preventing some of this now is to use the combination blades on your plows with your normal cutting edge and a squeegee type rubber back blade. Also, they've been putting a scarifier on the back of the plow, so you actually have a 3-piece blade. The cutting edge on the front, a scarifier, and then a squeegee to pull it all off. The other thing I started to use now is a segmented blade, where it's 2 or 3 foot sections of a blade that goes to the contour of the road. It pushes down into the your wheel ruts, and then it stays up on the high parts. So they're claiming they're probably getting someplace between 30 and 40% more material off the road per pass with these segmented blades. The state's bought some. I'm waiting to see what the results on some of these are. They seem to be the way to go. They use them in Europe and other places. The other thing to do with hard pack is you need to, it's like a toothed roller that can go in and break them up. In the past, we used graters and scaffolded it off to get it down low enough to start working. Okay. This is direct application. Before a storm, put the stuff down, spray it down, spray it on. And you can use any of your liquid products to do this. You know, and you're going to be putting this down at a fairly high rate. But, and, you know, you're looking at someplace around 30 to 50 gallons a lane mile for application. So, you know, it's a little more expensive to put down, but at the end of the day, it may cut out a couple trips and get you a little lead time to get back on to plow these. There's some material out there today. Check with my vendors. If I was you, I would check my vendors. I know of one for sure. I'm not a salesman, but if you use this product they have, you can reduce your salt by probably 40%. It's going to be actually getting to the drainage areas on a direct application. So, okay. Have you considered the environmental impacts? It's a yes or no.
Looks like we have all yeses.
Well, I'm very proud of you people. That's a great thing, I guess. When we're looking at this stuff and we're looking at what we're using, I would say the best material to use on today, and I'm not talking about the other chemical, I'm just talking about your rock salt. If you use larger stone, you're going to find that you're going to be melting at a lower temperature, because the rock will be there as it melts slowly. If you use fine salt, like solar salt has it's so fine that once it melts, it's gone. It doesn't stay long. The other thing is solar salt has more water in it than the rock, because the rock is a solid. But if these are treated, the best treatment is on the larger rock. The finer rock, like I said, if you use the solar or some of the pulverized out there, your liquids won't stay with them very long if you're using a combination. Yes, the organics will hang on because it's organic and it's sticky, but you'll have a lot better results if you're using the rock salt. Like I said, you can always use your treated salts, but you probably need a combination if you have really warm weather. The treated salts, basically you're throwing extra money away that you don't need. The other problem is that if you have to order your salts from the state or your contracts, if you don't use it, you're going to pay $4 a ton to have the state store it store it for you. Otherwise, you have to have it brought in and kept in pile. So I think that's about all I've got with that. That should be the last slide, Amanda. Yes. So if anybody's interested, you can contact the office if they'd like me to come and do a in-field visit or teach a class for a specific group. We do that. Our technical assistance is part of that.
It's 10 o'clock.
And it's 10 o'clock. And we also do, classes, requested classes, and Amanda lines a lot of that stuff up for us. But if you need to get a hold of me, my phone number's at the bottom, and my email's at the bottom. I'll be glad to answer any questions you've got afterwards. Amanda, do you have any questions that were brought to you?
Yep, we have one in the Q&A. It says, your thoughts on using liquid blend while plowing snow? We have access of sodium, calcium, and beet juice. If so, what percentage of mix/blend would you recommend?
You said you're using it on truck, was that?
While plowing snow.
Okay, if they're using, you should, if they're doing any of that premix stuff, should be around 7 to 9 gallons per ton. Maximum. Of course, now there's another new thing that's out that they're calling slurry. So what the slurry does is you grind the salt down a little more on the truck, and then you're using 30 gallons. And it's instant work. But I would say if you're going to use that and you use an onboard system, most of them are using like a SureFlow pump or a electric pump. The calibration on that is pretty simple. They pretty much, if you use what's coming out of the pump, that's pretty damn close to what you're going to need. So whatever it is, that's what you would use. But that's about all I can give you on that. 7 gallons, that's a pre-mix, pile mix. And that's what you should be using coming off the truck, because what you're basically doing is you're pre-wetting it, the salt as it comes off the truck, just as it would be if it was in a pile mix, pre-mixed.
Looks like it's it.
I appreciate everybody's time today. Like I said, I've got a couple of classes coming up around the state in the next month or so. And if you need anything else, you need a class of any of our people, get a hold of the office. Like I said, I can come out and do in-persons, teach a class. Or I can even take a look at your products and see if there's something we can talk about or enhance what you've got. So other than that, I thank you very much for your time. And I'm done.
Thank you, Jim.
Thank
Thank
you.
you guys for coming today. And we'll see you after our workshop season.
Yes.
Have a good rest of your summer and fall.
And you too. Thank you.